Hello everyone. In today's session, we are going to see how we can minimize the Boolean expression by using simplification of Boolean algebraic laws. So these are all the basic laws which we have learned already. So we know the law of identity, which says that A is equal to A bar is equal to A bar. Commutative law. A into B is equal to B into A plus B is equal to B plus A. Associative law, instead of having two variables, here we will be having three variables. So A into B into C is equal to A into B into C. A plus B plus C is equal to A plus B plus C. Idempotent law, which says that A into A is equal to A and A plus A is equal to. There is something called double negative law, which means that A complement of A complement is equal to A. That means A double complement is equal to A. Then we have the complementary law, which says that A into A bar is equal to 0 and or A plus A bar is equal to 1. Law of intersection says that A into 1 is equal to A or A into 0 is equal to 0. Law of union, A plus 1 is equal to 1, A plus 0 is equal to E. The most famous De Morgan's law, where A plus B the whole bar is equal to A bar plus B bar, or A plus B the whole bar is equal to A bar into B bar. Distributive law, which says that A into B plus C is equal to A into B plus A into C, or A plus B into C is equal to A plus B into A plus C. Law of absorption states that A into A plus B is equal to A, or A plus AB is equal to. Law of common identities says that A into A bar plus B is equal to AB, or A plus A bar B is equal to A plus B. So these are the most common laws which we use in simplification. So let us see a few examples of simplification. Right? So here, simplify A into A bar C. We know that A into A bar is equal to 0. Check here. A into A bar is equal to 0 in complementary law. So we can say that here this A into A bar will become 0. So 0 into C is equal to 0. Anything into 0 is 0. Or otherwise here, law of intersection says that A into 0 is equal to 0. Right? So the answer for first example is 0. Next one. We have to simplify ABCD plus ABD. Let us simplify. First, we will take the common terms outside. So take A, B, and D outside. We will get ABD into C plus 1. C plus 1. Anything plus 1 is equal to, any variable plus 1 is equal to 1. Check here. A plus 1 is equal to 1 according to the law of union. So C plus 1 is equal to 1. Variable into 1, that is A into 1 is equal to A, right? So ACD into 1 is equal to ACD. We cannot simplify it any further, so that will be our final answer. Going to the next example, A into A plus B is equal to. So we are going to simplify A into A plus B. We actually have a direct simplification for this, which says that law of absorption, A into A plus B is equal to A. Right? So otherwise, you can also simplify it step by step. Just expand this equation. A into A is AA plus A into B is AB. A into A is A. Again, take a common from this. So a into 1 plus b. 1 plus anything is 1. Okay, so it is a into 1, which is, or otherwise directly you can use the law of absorption and say that a into a plus b is equal to a. Carrying on to the next example, ab plus abc plus ab into d plus c. Okay, so here again, in all these three terms, AB is common. So you can take AB common. So first term, we will have 1. Second term, C. Third term, D plus. So here, 1 plus any variable is 1. So AB into this 1 plus C is 1. This 1 plus D is 1. 1 plus C will be equal to 1. So your final answer is going to be equal to AB into 1, which is nothing but your AB. Done. Going on to the next example. xy plus xyz plus xyz bar plus x bar yz. Okay. Let us take xy common in the first two terms, xy into 1 plus z plus the next two terms as it is. Okay, 1 plus any variable is 1. So this becomes 1, xy into 1 plus the last two terms as it is. Now, take the common terms between the first two terms. Again, xy. So it becomes 1 plus z bar. Last term as it is. 1 plus any variable is 1. So xy into 1 plus the last variable as it is. Again, just take whatever is common in these two terms. When you take whatever is common, you get y. So y into x plus x bar z. Fine. So this is nothing but resembling a plus a bar b. We know that according to identification, like law of common identities, a plus a bar b is equal to a into b. Sorry, a plus a bar b is equal to a plus b. This equation, a plus a bar b is equal to a plus b. So x plus x bar z is equal to x plus z. So y as it is. So we cannot simplify more than this. So this will be our final answer. Next, let us go on to this. A bar, B bar, C bar plus A bar, B, C bar plus A bar, B, C. Okay. So again, from the first two terms, we will take whatever is common. A bar and C bar are common in the first two terms. Taking it outside, we get B bar plus B inside the brackets and the third term as it is. So in B bar plus B, we know that A bar plus A is nothing but 1. So B bar plus B is also 1. So A bar C bar into 1 plus last term as it is. Now in these two terms, we can see that A bar is common. So take A bar outside. So C bar plus BC comes inside. So this is similar to the identity again, A plus A bar B, which is nothing but A plus B. So here we get C bar plus B inside the bracket. So A bar into C bar plus B is our final answer. Next example, ABC plus AB bar C plus ABC bar. We have to prove that this is equal to A into C plus B. Now let us take the left hand side. Take whatever is common in the first two terms. AC into, sorry for the interruption. So ABC plus AB bar C plus ABC bar, where we take I think we finished this problem. Yeah. A bar B C D bar plus B C D bar plus B C bar D bar plus B C bar D. So we take whatever is common in the first two terms. B C D bar is common into A bar plus 1. Okay. So we know that any variable plus 1 is 1. So B C D bar plus the next two terms as it is. Again, taking what is common in the first two terms. So B and D bar are common. So with this C plus C bar inside the brackets plus B C bar D. Yes. So C plus C bar, we know A plus A bar is equal to 1. So C plus C bar is equal to 1. So B D bar plus BCD. So taking whatever is common in these both, uh, taking B common. So D bar plus C bar D. So we know that A plus A bar B is equal to A plus B. So D bar plus C bar D is equal to D plus C bar. Right? And so going on to the next problem, AC plus C into A plus A bar B. Okay, so we have to reduce this equation. AC, so first we'll multiply all the terms and get it. So AC plus CA plus A bar BC. Okay, so here AC plus A bar BC will be equal to A bar BC from the identity. Okay, considering AC as one term. Okay, and from these two terms, I'm taking C common, so it will give A plus A bar B. So A plus A bar B, we know is A plus B. So the final answer is C into A plus B. The next example, A bar B C bar D plus A bar B C D plus A B D. Okay, taking A bar B D common in first two terms. So we'll get C bar plus C inside the brackets and the last term as it is. So inside the C bar plus C is nothing but 1. So A bar BD into 1 plus ABD. And so here again, we will take B and D, which is common here. So inside the brackets, we'll get A bar plus A, where A bar plus A is 1. I hope this video was useful to you. Please give me your comments. Thank you.